Hi, today I'll be discussing 3 different types of case tools that can be used in project management. The first tool I'll be discussing is something called a Gantt chart. A Gantt chart is basically an informative chart that consists of various tasks placed against a time scale. This basically helps you keep track of certain tasks that need to get done. As you can see, this is the name of the Gantt chart up here. You can name that whatever you would like. The activity on the activity column is the name of the activity that will be taking place. The start date is the date that the activity will start. Plan start is the day that you plan to start the activity. Plan duration is how long the activity is supposed to take. The actual start is the day that you actually start the activity, and the actual duration is how long it actually took to complete the task. The percentage complete means that basically shows how much of the task is already done. So as you can see from up here, plan duration is this shading right here, which is this entire thing, because the plan duration is 5. Therefore, it is highlighted with 5 rows. It highlighted 5 rows. Also, the actual start is shaded in a light blue, and that is from the time that you actually start and the actual duration. So the actual duration is 4, so it started from 1, and the actual duration it took was 4 days. Hence, it spread it across from day 1 to 4. The complete percentage is shown by a dark shade of blue. So 25% of it is already completed, which is shown here. Actual beyond plan is if it goes across the intended plan duration. So as you can see here, the plan duration was for it to take 2 days. They actually started on the 4th day, but it actually took 8 days, which is 6 days more than it was originally supposed to take. Therefore, it stretched across from day 4 to day 12. Now, the shaded part that is green, that is completely green, is how much is completed in the percentage that already went across the planned duration. So this percentage here, which is the 2%, which is the original 2 days that it was supposed to take, these days are already completed. In addition to that, 1, 2, 3, 4 days out of the 8 days are already completed in the actual duration that it ended up taking. So there's still 4 more days to go. Sorry, there's still 2 more days to go in that duration, because 4 days are done here and 2 days are done here, which is 6, and therefore there are only 2 more days here. There is a way to highlight whichever row that you would like. So this basically highlights whichever period you want to see from. So if you want to see what is taking place on day 1, you can use this drop down arrow and go on column 1. This will highlight all your activities that are taking place on that particular day. So you can shift to day 4, and it will go to day 4, and it will tell you exactly how far you've reached, if you've started, if you've gone over your time limit, if you've gone over the duration, that kind of thing. So that sums it up for the Gantt chart. The next chart that I'll be discussing is the bullet chart. This chart basically shows a graphic illustration of a project as a network diagram that consists of numbered nodes that represents events or milestones. Basically, this table over here is what is used to translate to this chart right here. So as it goes, there are two activities here that have no predecessor. This means that you will start off with that. So you put a circle first and you label that as 1, and then you start. You label the first line as A and you label the second line as B. There are no predecessors here, so this will go to the next circle. This will just go to the next circle or the next activity that is coming after. T equals 5 days is basically the time that activity A is going to take, and T equals 6 days is the time that activity B will take. And this is how you demonstrate it on the chart. Next, you have activity C. Activity C is going to take 6 days to get completed, and so you label that T minus 6 days and you label that activity C. Activity C predecessors are A and B, which is shown here. So you see here it goes back to A and B. From there, activity D. Activity D takes 8 days, activity E takes 2 days, and activity F takes 3 days, and their predecessors are all C. This means that activity D, E, and F will be coming from C. So from C, it branches out to D, E, and F. And of course, you must label the time that it will take. So activity D will take 8 days, activity E will take 2 days, and activity F will take 3 days. Activity G predecessors are D, E, and F. This means that activity G will be coming from D, E, and F. And therefore, you will put a circle here where activity D, E, and F all lead back to G, all lead towards G. And of course, G takes T minus T. Of course, G takes 4 days to get done, and so you label that line T equals 4 days. H predecessor is G, and therefore, as seen here, the arrow is going from G, the arrow is going towards H, and H takes 2 days to get done, and that is shown here. To calculate the critical part using the PERT chart, this is how it's done. You calculate every part and you add it up to see which one is adding up to the most amount of days to get done. So the first part, B, C, E, G, H, which is this part right in the middle here, that part in fact is added up, when added up, is added to 20 days, which is the least amount of days in this part. The second part, right, so the second part of this is B, C, F, G, and H. That is in fact this part right here, and that part in fact takes 21 days to get done. And again, that is not the critical part because that is not the most amount of days that it can take. The third part, we have A, C, D, G, H, which takes 25 days to get done. And again, this is not the critical part because this is not the most amount of days it can take. The critical part of this PERT chart, in fact, is part B, C, D, G, H. This part, in fact, takes 26 days to get done and is therefore the critical part. And this part is the part that needs to be watched. The final technique that I'll be discussing is something called the critical part method. This basically is a technique that identifies activities on a critical part. It breaks projects into several work tasks, display them, and calculates the project direction for each task. So what I've done was I've labeled each box in colors to make it easier for you to follow along. So the earliest start and finish dates are highlighted in purple, the latest start and finish dates are highlighted in blue, the slack time is highlighted in a light red, and the duration that each task will take is highlighted in green. The arrows are highlighted in red. This identifies the critical part, which we'll get to later on. So firstly, the start date is 1 and the duration is 5. To basically get the earliest finish date, you add the duration to the earliest start date. So 5 and 1 is 6. From here, you carry the 6 across, because once this is completed, you can start with the next task right away. So you carry the 6 across and you do the same thing. You add this earliest start date to the duration, and 6 and 6 is 12, and you continue doing this for all the rest. However, if you have a break off here, you will still put, so 12 and 6 is 18, you would still carry the 18 across to all 3 boxes. But when you're going back to this one box here, when you're going back to only one box, you're going to carry across the largest start. You're going to carry across the largest earliest finish date in this box. You don't carry across the least number because you would like to know which one is going to finish last, and in order for this one to get done, you must have all 3 tasks completed, and so you carry across the latest finish date. And the latest finish date is 26, and again you continue adding to the duration and you get 30 and so forth. Okay, so now that we've discussed how to find the start and finish dates, the earliest start and finish dates that is, to get the latest start and finish dates you have to start backwards. So start with 32, and so instead of adding the duration time, you're now subtracting the duration time from the end time. So 2 from 32 is 30, and you carry the 30 across, and 4 from 30 is 26, and you carry the 26 across to each of the 3 boxes. The difference with this is, instead of carrying across the largest number, you're going to carry across the smallest number. And so after subtracting each one of these, the smallest latest time is 18, and so you're carrying across the 18, and from here you continue on subtracting the duration time. So 6 from 18 is 12, and carry across the 12, and 6 from 12 is 6, and 5 from 6 is 1, and that is basically how you get the latest start and finish times. So the final thing I'll be showing you is how to calculate the slack time, and the slack time is basically much time you have to play with. And to calculate that, you basically minus the earliest start date from the latest start date. So from here, 1 from 1 is 0, 6 from 6 is 0, 12 from 12 is also 0. And as you can see here in these 3 tasks, this is where you see the change. And so 18 from 24 is 6, so you have 6 days here as slack time. 18 from 18 is 0, you have no days here, and 18 from 23 is 5, you also have 5 days here, and the rest of the part is 0. Also, in the middle of the box is the name of each activity. If I did not mention that in the beginning, yes, that is the name of each activity. And this part, the critical part in this method, is basically highlighted by red arrows. This part means that you have no time to slack. There is no slack time here in this part. This is the part that you need to keep a close eye on, seeing that this is taking the most time in this part. So yeah, that's all for today. Thank you and bye.